Guys, let's look at this problem right here. This question is asking, in a particular case of Compton scattering, a photon collides with a free electron and scatters backwards. The wavelength after the collision is exactly double the wavelength before the collision. What is the wavelength of the incident photon? Okay, here the question is asking us to find out the wavelength of the incident photon. Now, according to the Compton scattering experiment, shift in the wavelength is given by this one. Delta lambda is equal to lambda 2 minus lambda 1 equal h over mc times 1 minus cos phi. Okay, this is the Compton experiment equation. Now here we know the phi is equal to 180 degree. Okay, here phi is equal to 180 degree, and this lambda 2 represents the wavelength of the photon after scattering. Okay, after scattering and this lambda 1 represents before scattering. Okay, scattering. Now let's look at the question. Here they have mentioned that the wavelength after the collision is exactly double the wavelength before the collision. So after the collision is like lambda 2 is equal to 2 lambda 1. That's what they are mentioning, right? So lambda 2 is equal to 2 lambda 1. If we plug this one in this equation, we can make this one unknown variable, right? So we can say lambda 2 is equal to 2 lambda 1. So this is going to be 2 lambda 1 minus lambda 1 is equal to h over mc times 1 minus cos phi. Cos phi. Okay, now let's go ahead and plug the values. This is going to be lambda 1, and this cos phi is negative 1, right? Because cos 180 degree, cos 180 is negative 1. Negative 1, that's going to make this one positive 1. So we are going to have 1 plus 1, that's going to be 2. So we are going to have 2h over mc. Okay, now this is lambda 1, and also we can say like if we equate this one to mc square, because we know that rest mass energy for electron is given by 0.511 mega electron volts. If we make this with the bottom part into rest energy equation, that's mc square, we can apply this one. Okay, so in order to do that, what we can do is we can multiply top and bottom by that one, this mc value, because if we do that, this is going to become 2hc, and in the bottom we are going to have mc square. Now we can go ahead and plug the values. 2 times 4, okay, let's see, h is Planck's constant. In electron volts, here we have this one in joule. In electron volts, that's equal to 4.14 times 10 to the power of minus 15 electron volts times 3 times 10 to the power of 8. Actually, this part is unnecessary. You can directly just plug it, right? Because we have h and mass also provided, that is 9.11. Yeah, right? Both way you will get the same answer. And if you apply this one also, you are going to get the same answer. So 0.511 mega electron volts. Mega is 10 to the power of 6 electron volts. And if you calculate this one, you are going to get 0.00486 nanometer. And if you want to express this one in picometer, this is going to be 4.86 picometer, and that's going to be the final answer. I hope this helps. Thanks for watching.